So you've probably heard the term active chilled beams thrown around in building design, but what are they really? Well, they're a super smart piece of tech for making our buildings comfortable and efficient. And today, we're going to break down exactly how they work.
It all really boils down to this one big question, right? How can we cool our buildings, our offices, schools, hospitals, not just effectively, but in a way that's also more efficient and genuinely comfortable for everyone inside? That's the puzzle that active chilled beam technology was built to solve. Okay, so before we jump into the active part of the name, we've got to get our heads around the basic principle, because the real secret here isn't about just blasting air. It's about using water to do the heavy lifting.
At its heart, a chilled beam is a pretty simple idea. You can almost think of it like a radiator, but in reverse. Instead of hot water making things warm, you have chilled water flowing through a coil, and that coil is the engine that cools down the air in the room.
So here's that process in its most basic form. This is what we call a passive chilled beam. It relies on a simple law of physics, natural convection. Warm air is lighter, so it naturally rises up. As it drifts over that chilled coil, it gets cooled down, which makes it denser, and then it simply sinks back into the room. It's this gentle, silent, continuous loop.
All right, so if passive beams are that simple and elegant, you might be wondering, why do we even need an active version? Well, that's where we unlock a whole new level of performance and control.
The key difference, the secret ingredient, is this one addition: primary air. An active chilled beam is hooked up to the building's main ventilation system, which feeds it a steady supply of fresh, conditioned air. And this air does more than just help us breathe. It's the catalyst that turbocharges the whole cooling process.
This table really lays it out nicely. Your passive beams are all about that gentle, natural convection, which is perfect for spaces with pretty steady, low heat loads. But active beams, they use that primary air to create forced convection, and this really powerful effect we call induction. And that makes them absolute workhorses for dynamic spaces, like offices or hospitals, where the cooling needs can spike up and down all day.
We just mentioned that key term, induction. This is so much more than just blowing cold air around. This is where the physics gets really clever and incredibly efficient.
So what exactly is induction? Well, it's a process where you use a small, fast-moving jet of air to pull or induce a much larger amount of the surrounding air to come along for the ride. Think about how a fast-flowing river can drag the slower water from the edges into its current. It's that same principle, just happening with air inside the beam.
Let's walk through it. First, that primary air we talked about gets squeezed through these tiny specialized nozzles, making it shoot out at a really high speed. This fast jet of air creates a low-pressure zone right around it. And, physics being physics, the higher pressure air in the room, which is the warm air, is naturally drawn towards that low-pressure spot. So the room air gets actively sucked up into the beam and over the chilled water coil. Finally, that newly cooled room air mixes with the fresh primary air, and the blend is gently distributed back into the space.
And the result of this whole induction thing is a massive multiplication effect. How massive, you ask? Well, take a look at this.
Yeah, 5x. That number really shows you the power of induction. For every single unit of primary air that the building's fans have to push, the beam induces up to 5 times that amount of room air to get cooled. And that right there is the secret to its efficiency. You're using a tiny bit of energy to move and cool a huge volume of air.
So, we've gone through the physics, which is pretty cool stuff. But what does all this clever engineering actually mean for a building? And more importantly, for the people inside it? Let's get into the real-world benefits.
The advantages are pretty compelling. First off, you get some serious cooling power, enough to handle spaces with lots of people and electronics. They're also incredibly energy efficient, mostly because water is just way better at moving heat than air is, meaning the building's main fans don't have to work nearly as hard. For the people in the room, the comfort level is a huge deal. The low-velocity air means you don't get those annoying drafts. And since there are no moving parts like fans inside the beam itself, they're exceptionally quiet. Plus, their slim profile makes them a fantastic choice for upgrading HVAC systems in older buildings where space is tight.
And you can see where all these benefits really shine. This tech has become a go-to solution in really demanding places, like big commercial offices, schools, hospitals, labs, and hotels. Basically anywhere that comfort, efficiency, and quiet operation are non-negotiable.
Now, while the principles of induction are universal, the specific engineering that goes on inside the beam can make a world of difference in performance.
So let's use Frenger's designs as an example of how this technology can be fine-tuned for excellence.
You know, the real magic is often in the details, like the precise design of the nozzles that release that primary air. Frenger's patented burst nozzle design, for example, is engineered to do two things at once. It maximizes that induction effect while also cutting down on the noise right at the source.
And the innovation doesn't just stop at the nozzles. The entire path the air takes is optimized. Things like concealed vanes guide the air for better performance and a cleaner look. Some models even have a 360-degree discharge for the most even air distribution you can get. And a key principle they use is the Quande effect. That's the tendency for a stream of air to kind of stick to a nearby surface. Here, it makes the cool air hug the ceiling, spreading out wide and falling gently into the room instead of just dumping straight down and creating a draft.
So what's the bottom line from all this advanced engineering? Well, you get some truly impressive cooling power.
That's right, Frenger's beams can deliver over 1,050 watts of cooling for every single meter of length. And listen, that's not just some theoretical number from a spreadsheet. It's a performance metric that is proven time and again in their own state-of-the-art in-house testing labs.
And this commitment to testing is so important. By having their own labs for climatic, acoustic, and even photometric testing, they can guarantee that every single product performs exactly as promised in the real world, from how much it cools to how loud it is.
And that's pretty much the rundown on how active chilled beams work. For anyone out there who wants to dive deeper, maybe geek out on the technical data, check out some case studies, or play with calculation tools, the Frenger Systems website is the place to go.
Which brings us to a final thought. As our buildings are expected to perform at higher and higher levels for both energy use and for the people inside, you have to ask, is your next project ready for a climate solution that's smarter, more comfortable, and just fundamentally more efficient? Hey, thanks for joining us for this explainer. If you have any specific questions about your own project, the Frenger technical team is always ready to help. We'll see you next time.